and get a better understanding of some of the projects available to you. Followed by that, we're going to have our intro to machine learning. This is where you actually get into the nitty-gritty math and data science behind machine learning and actually understand what some of the terms we'll be throwing around are. And then finally, the last workshop will be intro to feature engineering, which will be an intro into how to deal with some of your data and tackle some of the more confusing problems you might face when trying to collect data for your actual machine learning projects. And then at 3:30, we'll be releasing the competition package, as John said. That competition will have about a 5-hour window, so it'll be up to you guys to work as quickly or as spread out as you'd like for that. So without further ado, I think I'll share my screen and we can jump into intro to developing.
So while Daniel is sharing his screen, one point I forgot to mention is that in order to be eligible for a coding competition prize, you must be a paid Western AI member. So if you think $20 is worth hedging your bets for, then make sure your membership fee is in and you'll be eligible for those $500 prizes. Otherwise, you'll still be able to compete, but you will not be eligible for any prizes. So just a quick note there.
All right, hopefully everyone can see the screen. We're good to go.
Yep.
All right, perfect. So welcome everyone to the first workshop of the day. We're going to be going over the intro to development, have some tips and tricks for you guys, as well as going over the actual environment you'll be working in and the environment we'll be working in for the rest of the day. So let's get into the workshop. So first things, development with AI. Here are some things that you guys should definitely consider. First is your file storage and organization. When it comes to AI, you deal with a lot of data, different model files. These we'll explain a little bit more when we get into it. But first thing you need to understand is that where you store these and how you organize them, and making sure that when you need access to a certain file, that you have access to it. Code and data. Well, your data is basically the heart of any machine learning or AI project you work with. So making sure your code can actually interact with that data is a big deal. Your library access. So one of the workshops we'll be touching on is Python libraries. And these libraries help make a lot of the complex math that comes to machine learning a lot simpler with built-in functions that we can add into Python. And then hardware access. When you get into some more advanced machine learning projects, hardware plays a big fact. If you guys don't have the most advanced computers or you don't have the strongest GPU, there's ways around this. But when it comes to some of the more intense processing power that you need for AI, hardware plays a big deal. So before anything, we're going to jump into the do's and don'ts of AI. So when it comes to the do's, do keep your data organized, whether it's local or cloud-based. As long as you know where your data is and you have access to it, there usually isn't an issue. So for example, if you have all your data saved in the Google Drive, and you have no way of really accessing that through your local machine, you might want to think about either moving your data or moving your environment where you work in. Do choose an appropriate level of complexity. Problems in programming come in all different shapes and sizes. So a lot of the time, people like to jump at it with the most cool, complex machine learning model they can think of. This isn't always the best idea. And part of this reason is because when you overcomplicate a problem, yes, you might be able to say that, this neural network that I made is perfect for solving this very basic problem. A lot of the times you don't even need to focus on an ML solution for it. A lot of times you can use a simple decision tree or concepts that aren't nearly as complex and advanced as some of the buzzwords that you continuously hear when you hear the terms AI and ML. Do focus on a valid form of deployment. Machine learning is fantastic. If you can make a model that can tell the difference between a cat and dog 99.8% of the time, that's great, it's reliable, but it's still just code. What deployment is actually taking that code and taking that cool machine learning model that you made and putting it in a form that's actually useful and accessible. So whether that be a mobile app, a web app, a web API that someone else's software can call, whether that be integrated into an actual physical component. Deployment really makes your AI actually useful, and a lot of time, like an AI model is only a small part of an overall project. So it's important to always keep in mind what your end goal is with this model and what your end goal is with the AI that you're using. Is it just purely to create something in the realm of machine learning, or is it to serve an actual purpose at the end. Then we have do split your data into a validation set. So now this may not mean a lot just coming out of in the beginning of this workshop here, but what we're basically saying here is that machine learning likes to learn. That's the whole point of machine learning, is that we're using sets of data to help train and make this model smarter and make decisions more accurately. So this is kind of analogous to when you're taking a test. If you're studying off a test bank that has the exact same questions on your final exam, you're going to do very good on that final exam. You may not know a lot about the content, but you've trained off this exact same data before. In the same way, having a separate set of data just for testing purposes is very important in AI and gives you the most accurate understanding of whether or not you're actually accurate with the model that you have. And then the second last do we have is do make sure your data is reliable. Data, a lot of times you have to make sure you're getting it from a valid source. So when it comes to like asking 5 of your friends for, what's their favorite type of candy or something along those lines, like that is not considered reliable data. If you don't have a source of getting your own primary data, there are a lot of resources online that help you get data sets that have been used in multiple projects before, Kaggle being one of them. We're going to explore some other forms of getting data sets a little later on in the other workshops as well. And then finally, make sure your model works on different types of data. So this basically means that if you are trying to create a software that can help someone decide what to wear, for example, based on the weather, then you can, all your training data will be able to teach your model basically everything that you need, but then you have to make sure that that model also performs with what your final user will be inputting as data. So their wardrobe, maybe the location they live in. If your model was purely designed for northern Canada, then the weather there and the information you might be experiencing there may not be completely accurate to where your final user might be. So making sure that all of these different checkpoints are sort of done and taken care of is one great starting point to getting started in your AI development. So next, we're going to jump into the don'ts of AI development. So first and foremost, do not use AI as a solve-all tool. AI is fantastic. AI is a super powerful data science tool, but not all tasks require AI. There's a problem that a lot of people run into where they just jump to AI for all of their problems and a solution for everything. And this really does overcomplicate your project, and it goes back into the previous do, which is do choose the appropriate level of complexity. You don't need a ML model that can be replaced with 2 if statements. You don't need super complex neural networks all the time. So make sure that AI is the right tool to use at that specific moment, because AI, just throwing AI at everything isn't the greatest idea. The second point is somewhat similar. Don't assume that using AI will make your product a success. When it comes to things like personal projects and hackathons, a lot of people assume that, oh, wow, I integrated AI into my project. This has to win something now. That's not always the case. AI is an interesting technology for sure, but for a product to be a success, you need to worry about all of its components. And a lot of times the fallacy of thinking that just because I use this one cool type of technology should mean that my project is great and successful. Project success comes from an all-around understanding of what you need in your project and the different aspects that come together in your project, not just, ooh, cool AI project. Then don't mix your training and testing data. So make sure that your data is actually separate and your data is actually secure. So if your model accidentally runs off your testing data by accident in one of its training sessions, that testing data is completely invalidated now. You can no longer use it for testing. And that's because it's already been seen, it's been compromised. You have to make sure that you keep these things separate. And then we have assume that your data represents all data. You have to understand going into machine learning and AI that the data you have is just a sample. It's not an understanding of all cases. It won't be 100% perfect all the time. Expect some error whenever you're dealing with these things. And when you do see error in your actual machine learning models, it's okay, that's expected. There's always room for improvement when it comes to that. And then final don't assume that you need to build everything from scratch. When it comes to software development and AI specifically, a lot has already been done for you. If you were building everything from scratch, you'd be taking a long time to solve a very simple problem. So feel free to use either libraries that have been created or even other models and just build on top of them. So as we get deeper into actual machine learning content later on after the break for projects to talk, then you'll get an understanding of all the different machine learning models that we have available to use with like recent years. And you'll have an understanding of what you can build on top of rather than just create everything from scratch. But now we're going to jump into understanding your environment. And by that, I mean the actual environment where you do your software development and where you create your AI models. So here's a couple tools that I'm pointing out for AI specifically. So if you're working in Python, Google Collab is a fantastic resource, and it's probably what we're gonna be using for the preceding workshops following this one. So Google Collab and the following Jupyter Notebook are very similar. One just runs cloud-based, and then one runs locally. So what these are Python notebooks. So for those of you who are unfamiliar with notebooks, they're basically segmented off pieces of code that you can run individually. And it's just sort of organized in a different way from your standard programming environment. So Jupyter Notebook is the equivalent of Google Colab locally. It will use your local files as well as your local hardware. And then MATLAB has its online sort of environment, which also has notebook capabilities and additional machine learning add-ons. So as Western students, we all have access to that. So that's fantastic. So now we're going to take a look at what the difference between notebooks and scripts are. So notebooks are what I just described with the segmented off cells. So you can run chunks of code independently from the whole thing, while scripts are just basically kind of like a giant Word doc of code where everything is in one blurb and it runs all together. So when it comes to notebooks, they allow for the separation of code, so you can run code in individual blocks. This works really well for prototyping because you can sort of test individual features without having to continuously run all your code. You can run your first bit of code separately than your second bit of code, and this lets you sort of figure out, how to test new additions that you've made. And then a third thing about notebooks is that your variables are stored in runtime. So what this means is that in normal Python programming or with any other language, for the most part, if you run some code, it's reliant on the code that you've written before. So you have to run it all at once with a script. But with a notebook, if you've already ran a code, it kind of just remembers what happens with that code and just keeps it stored so that when you run new code, it can utilize that previous code without having to run it over and over again. Then when we get to scripts, scripts are better for debugging. Scripts are, again, just the giant sort of Word doc bunch of code. These are better for debugging. They have built-in debugging tools. They're also reproducible because everything will run at the same time. So every time you run it, it's consistently giving you the output that it'll always give. And then scripts are standard for production. When you're actually producing and deploying your model in the end, notebooks usually aren't the way to go. Scripts generally are used as a standard everywhere in terms of software development. Then we'll jump over to comparing Python environments. So like I mentioned, two of the notebook environments are Google Colab and then Jupyter Notebook. So when it comes to Collab, these are drive-based files. So when it comes to the Google Drive, I'm sure you guys are all familiar with it. It's cloud storage for your files, which is fantastic. This means that you're not taking up space on your own computer. You have access to all the files that you have on Drive when you're doing your development. It's also collaborative. So kind of think of it as the software Python coding equivalent of Google Docs, right? Like Google Docs is to Word. In Word, you work by yourself. You can send the file and share it, but at the end of the day, it's a local file. But with Collab, it's kind of like Google Docs, where you can have a team of people working on the code at once, and when you save it, everyone can see it. And then Collab also has access to virtual hardware. So what I mean by this is that if your computer is not the most high performing, Collab actually provides access to some pretty impressive hardware devices. They use a P100 graphics card, if that means anything to anyone, and that's on the free level. And then we have Jupyter Notebook. So Jupyter Notebook is the local equivalent to Collab. It uses your local files, which, if you are more comfortable not working with data that's on the cloud, that makes perfect sense. So maybe you want everything locally stored. It also uses your physical hardware, so this gives you access to exactly what hardware your computer has. So if you have a great computer, that's great. If you don't, maybe you look at other options like Collab. And then it uses your local library. So Google Collab, for example, everything, all the most like popular libraries and imports are sort of built into it. But with Jupyter Notebook, you kind of have to add them yourself. Okay, so now we'll go through an intro to Google Collab. So basically, it's a zero configuration required for the most part. You sort of just jump and play, which is fantastic for beginners because you don't have to worry about accessing all these different libraries and additions that you would when you're setting up your own local environment. You have free access to GPUs. So there is a pro version of Google Collab, but for the most part, anything that you'll be doing will only require the free version. And these free access to GPUs gives you some of the, fastest performing GPUs that you'll probably use, like a classic laptop or even most desktop PCs won't have access to that type of processing power. It's also easy sharing. You can send a link, you can add people to like a Drive document, and it's a collaborative environment, so it's great for group projects. And then, like I said, Drive access. So you don't have to worry about your local files, you actually just work off of the Google Drive. So now we will quickly, as I switch from my screen share, we will drop over to the actual code examples. I can show you a bit on actual Collab. Hopefully everyone can see this. So right here we have the Google Collab environment. So like we said, this is browser based. So you don't have to download anything, nothing additional. It actually runs straight off your drive, which is fantastic. So here we have two types of cells we can look at. We have code cells here, and we have text cells. So the code cells have actual code in them. So you can run a piece of code, and then we create a variable A, and we'll explain variables in a bit and everything Python, and then the code runs. We also have our text cells. This is more for either if you're giving this notebook to someone or just for your own organization. You can have text cells where you have basically works with all of the text functions you would have in a normal like Word document, but you can have them in sort of blocks in addition to your actual code, which makes it a lot cleaner and a lot easier to explain concepts. So text cells have access to things like LaTeX. You can have your mathematical functions really easily written out here if you need. You can move your cells up and down. Like there's a lot of functionality there. So like I said, it's built basically to work with Python. It's built on top of Jupyter Notebook. So we'll run this piece of code right here. So all this does is it imports a library, prints a piece of text, sleeps, and then prints a piece of text again. So we get the print that it's sleeping. It'll take about 30 seconds to actually print done sleeping. So we could just let that run in the background while we move on. And then we also have access to system aliases. So I'm not sure if anyone's familiar with working with command line prompts or bash code. Basically, this is just the access you have to that. Any line you begin with an exclamation mark will run as that. So this is just an example of showing everything inside of this bin directory. You can see this is done sleeping now. So that's fantastic. So this will give you basically all of the files and things that are in a certain directory. Exact here, you can sort of set up shell and bash code here too, where you're running an echo here, and then you get your message. That's not super applicable to us because we'll be focusing on the Python side of things, so don't worry about that too much. Magics basically just let you, if anyone's familiar with HTML, you can run some HTML stuff in these cells as well. And then automatic completion. Basically, if we have NP here, this actually isn't doing the automatic completion, but basically you can. It helps like any other environment where it'll give you tips as you go, and it'll like make predictions of what you're typing. Then we have the formatting exception formatting. So sometimes you guys might notice if you ever worked with it in like a local environment that your errors don't make sense. It just tries to help you point out these errors a little bit better. So that's like a good breakdown of what Collab is and what the environment we'll be using for the next little bit. So I'm gonna just put it out to any questions there. So feel free, if you're okay with your voice being recorded, feel free to verbally ask your question, just unmute. And otherwise, you can drop them in the Discord chat Yes, Pooja.
So in this Google Collab, whenever we want to write a code, is it like we create a new notebook and then start doing coding? Is it like that?
Yeah, so basically, when you create a new notebook, you get this sort of blank document, and then, yeah, you can have your whole project in there. If you want to create extra portions to a project, a notebook that already exists, you add a new cell of code or text, and then you just add additionally into that.
Okay, yeah, thanks.
It's just like when you're in Google Drive creating like a Google document, Google Collab is no different.
If you go into your Drive and when you click, add a document, you get your standard options of your docs, your slides, your sheets, and then under a More tab, there's the additional stuff that Google has, one of them being a Collab notebook.
Okay, awesome. So you guys can see my screen, right? Daniel, can you see my screen?
1 second. Yes.
Yeah. Okay, awesome. So when you guys typically go into your Google Drive and you want to open up a new file, right? Normally like a Google Doc or a Google Sheet. What Daniel just showed us is in More. So you hover down to More, you'll see Google Collaboratory, click on that. And just like any other Google document, you now have a cloud-based file that you can code in. So no need to download anything. It's very simple. And just like any other Google document, it'll be saved automatically once you exit the cloud environment. So just like it is, and without any setup, you can just begin running code. So pretty straightforward. Definitely recommend opening this up over the next few tutorials so you can code along with Daniel and the other educational directors and get a feel for it. If you find the pace to be a bit too fast, we will also be recording the sessions and putting them up on YouTube. So no worries there. Maybe it might be better just to try and understand the content and then follow along with code at a later date. But I'll leave it up to you guys and pass it back off to Daniel.
Perfect. So just before we get into the next session, there was a question in the Discord. Someone asked, for any new projects, would you say start and create the majority of them with notebooks and then towards the end test with scripts? Or would you choose to go with one option for the rest of the project? So basically, to sort of just explain this, your process, a lot of people have their own processes. Some people just stick with scripts the entire time. But what tends to happen is with a notebook, it's perfect for prototyping. So when you're trying to create a model and you're sort of still playing around with parameters and a lot of the sort of nitty-gritty stuff that's involved with making it, the final model to be used, you can tend to use a notebook, and then you can actually play around with individual portions of code so that you can sort of test different portions of your actual model individually. Then once you're comfortable with that actual model, you can either take that code and move it to a script where you actually use it for deployment, or you can export the model. There's different ways to export models. And then you can use that exported file in a script that's, again, focused towards deployment. So usually whatever final project is, like whatever your project is in its final form, will run off a script, and the notebook is more of the designing and planning phase of that actual development. Hopefully that answers your question. Awesome. Okay, then I guess we can sort of jump into the introduction to Python, and then we can actually give you guys something that you can actually use in this notebook environment